Transits in space. In astronomy, transit refers to the passage of a celestial body between another celestial body of larger angular size and the observer. From the point of view of the observer, the obscuring celestial body moves in front of the obscured body, blocking the view of a fraction of the surface of the obscured object. Sample of transits are planetary, exoplanet, moon or satellite, and solar. A planetary transit is when a planet passes in front of a star or another celestial body from observer's perspective. The planet is usually seen as a dot moving across the star face. From Earth, we can observe transits of Mercury and Venus as they pass between the Sun and Earth. An exoplanet transit is when an exoplanet, or extrasolar planet, is a planet outside our solar system, passes in front of its host star, causing a slight dimming of the star's light. This method, known as the transit method, is commonly used to detect and study exoplanets. For example, planet Kepler 1649c transit of the host red dwarf star, Kepler 1649. A moon transit is when one of a planet's moons or natural satellites passes between the planet and the observer, casting a shadow or moving across the planet's disk. For example, the transit of moon Io across the planet Jupiter. Saturn quadruple transit. This Hubble movie shows 4 of Saturn's moons moving across the face of their parent planet on February 24, 2009. Icy moons Enceladus and Dione are on the left, while the large orange moon Titan and icy Mimas are on the right. Satellite transit occurs when an artificial satellite, such as the International Space Station, ISS, or a communications satellite, passes in front of the Sun or another celestial body from an observer's perspective. Several photographs assembled in sequence show the ISS, in silhouette as it transits the Sun at roughly 5 miles per second, Wednesday, June 24, 2020. This composite image made from 6 frames shows the ISS, as it transits the Moon at roughly 5 miles per second, Saturday, December 2, 2017. Solar transit refers to any small celestial body, such as a satellite or a planet, passing directly between an observer and the Sun. For example, the ISS transiting the Sun. While such events can include planetary transits, like Mercury or Venus, solar transits more broadly include other smaller objects as well. Comparison between Moon and Satellite transit. Moon transit. Natural moon passing in front of its parent planet or star. Transits of Jupiter's moons, for example, Io, Europa. Visually striking with shadows. Observable using telescopes. The Moon appears as a small dot or shadow moving across the planet's or star's face. Satellite transit. Artificial satellite passing in front of the Sun or another celestial body. ISS transiting the Sun or Moon. Brief. Requires precise timing. Can be captured in high-resolution images or videos. The satellite appears as a small silhouette quickly moving across the bright disk of the Sun or Moon. Comparison between planetary and solar transit. Planetary transit. Planets passing between an observer and a star. Transit of Venus, transit of Mercury. Seen as small dots moving across the star's face. Solar transit. Any small object passing between an observer and the Sun. ISS transiting the Sun, any planet passing the Sun. Requires precise timing, location, involves any smaller object. Mercury and Venus are the only two planets in our inner solar system that orbit the Sun inside Earth's orbit. Mercury transits occur about 13 times per century, Venus transits occur twice every 108 years. The most recent transit of Mercury occurred in November 2019, and the next one will take place in November 2032. The last transit of Venus was in June 2012, with the next not happening until December 2117. The transit of Mercury on May 9, 2016. Mercury is visible as a black dot below and to the left of center, and sunspot AR 2542 is prominently visible above center, as well as AR 2543 below it and AR 2544 on the upper left edge of the Sun. On May 9, 2016, Mercury passed directly between the Sun and Earth, making a transit of the Sun. NASA's SDO studies the Sun 24/7 and captured the 8-hour event. The images of Mercury's journey across the Sun were taken in a wavelength of extreme ultraviolet light. Transit of Mercury 2019. Visible through the 171 angstrom filter on SDO. Visible through the HMI instrument on SDO. Transit of Venus 2012. Venus transit visible through the 171 angstrom filter on SDO. Venus transit visible through the HMI instrument on SDO. Transit's use. Photometry. The amount a star dims during a transit can help astronomers estimate the size of the orbiting planet. Radial velocity. This method can help astronomers estimate the mass of the orbiting planet. Combining methods. Scientists can use both photometry and radial velocity to calculate the density of the planet.